Hello everyone. Today I'll be presenting our project on capacitive touch panels. We'll focus on electric field distribution and how charging and discharging work. Capacitive touch is the most commonly used technology in smartphones and tablets today. When a finger gets close to the screen, the human body's conductivity changes the local capacitance. The controller chip notices the voltage change and can tell that the touch has happened. The panel has crossing conductive strips along the x and y-axis. These form a grind of tiny capacitors. When the finger touches the panel, the capacitance increases and changes the voltage. We can model this as a basic RC circuit, made of a resistor and a capacitor. What is capacitance? A capacitor stores electric charge. The formula is C equals epsilon times A over D, where C is the capacitance, epsilon is the dielectric constant, A is the electrode area, D is the distance between electrodes. Capacitive touch works because your body changes the electric field. Inside the panel are conductive grinds arranged like a cross. There are two kinds of capacitance. Self-capacitance. Each electrode forms a capacitor with ground. Mutual capacitance. Capacitance forms between two cross electrodes. In self-capacitance, when your finger gets close, it increases the capacitance. Your body acts like a conductor and affects the electric field. In mutual capacitance, the controller keeps checking the capacitance at each point. If it finds unaccepted changes, it knows there was a touch. Let's look more closely at self-capacitance. Each sensing electrode connects to ground. When the finger gets close, it forms another path for electric charge change. Think of it like standing over a metal plate. The closer you are, the stronger the interaction. This method is simple and low cost, but it can only detect one touch at a time. In mutual capacitance, there are two sets of electrodes, horizon and vertical. Capacitance appears at each intersection. A finger disturbs the electric field there, lowering the capacitance. Think of it like standing on a tic-tac-toe grind. Stepping on a cross point blocks part of the field. This allows accurate touch detection and supports multi-touch, but the design is more complex and expensive. Here is a comparison of two methods. Structure. Self-capacitance use single electrodes to ground. Mutual capacitance use intersecting electrodes. Touch detection. Self shows increased capacitance. Mutual shows a drop or imbalance. Multi-touch, only mutual supported. Cost and complexity. Self is simple and cheap. Mutual is more costly and complex. Accuracy, mutual is better. And this is the math behind it. The first is the math when charging, and the second is when discharging, and the last is the differential equation. We solve this using Laplace transforms, a loss analysis of both transient and steady-state behavior. The time constant tau equals RC. A small RC means fast response but more noises. A large RC is slower but more stable. Engineers must find the right balance between speed and reliability. Capacitive sensors are used in many devices, like water detectors, spans, and distance sensors. They can work with RC filters and reduce noises. And this is our conclusion. The whole systems can be modeled with simple equations. Using Laplace transforms helps us analyze and improve touch panel designs. Thanks for your watching.